everyone. Today we will talk about the first article in the magazine and application in earthquake. 没开麦克风，你看我开，哎，好。I believe all of you have already read it. This guideline is about studying the 91 earthquake region of Taiwan and when he was at home with his mother. In the first part, they went to the 科隆古为圣地。科隆古 more country this picture and that is the inside. In the Kerongpu Forest Gallery, they saw the castle and the forest. The castle and and after that, they went to the earthquake engineering home. Yeah, and they built a building model there. In the second part, Danny was at home with his mom and there's a big earthquake was happening. I don't know why they cancel line in the earthquake. And now I will talk what should we do when an earthquake happening again. First, we should open the door and turn off the light. And second, cover under the table. So prepare the earthquake survival kit. What should we do in the earthquake survival kit is in the magazine, so I don't say it. And before we can take the elevator. We should take the stairs. Yeah.
Okay. So now we're going to talk about some other facts. You guys hear this? Okay. So we are going to talk about some other facts of earthquakes. So first we're going to talk about how they measure how big an earthquake is. And we use this word magnitude. And magnitude, it usually means the size of something. We can use it in earthquakes to say how much energy it releases, how much energy it gives, or we can use it in astronomy to describe how bright the stars are, or we can use it in math. We call it 数量级. Go ahead. And okay, so there are a few scales we use to measure to compare those earthquakes, and the one which is more common is the Richter magnitude scale. It is developed in 1935, a long time ago, and by two professors in Caltech. And they first developed this scale to measure the local earthquakes in California. Okay, so it was only for a small region of use. And they calculated this by measuring the amplitude. This is the amplitude. You know what I'm talking about, right? Of those waves, and they use formulas to change this amplitude into the energy it releases, and then they calculate the number by using logarithm. But however, the problem of this scale is that it is only accurate for those earthquakes which are nearer. So there are earthquakes which are further and they are bigger. We have to use the moment magnitude scale to get a more accurate, to get a more precise number. Okay. And yeah, just they subtract this number only to make the number look closer to this one. So that's why they have to subtract 10.73. It's just, they're just trying to make those two numbers look similar. Okay, now we talk about faults. A fault is a fracture in the rocks, yeah. Everyone knows that, right? Or you wouldn't be here. Well, and we have a few kind of faults. We have a strike slip fault. A strike slip fault is a fault like this. Strike slip, okay? And there are also, sorry about that one. I caught that one wrong. It's a dip slip. It's a dip slip. And a dip slip is something like this. The fault here, it slips this way, vertically. Okay. So this, we call this a reverse dip slip, 逆断层. Alright. And this one, sorry about this, right? So this is a normal dip slip. Alright, sorry about that. Okay. And if it goes the other way around, it's a reverse dip slip. Okay, and oblique slip is that just when a fault, it has the horizontal and the vertical movement at the same time. We call that the oblique slip. Okay. And now the famous Cheolungshu fault. It is a reverse dip slip fault, and it stretches for 80 kilometers, which is quite long when you consider just how small this island is. Okay. And on the morning of September 21st, 20 years ago, and this fault causes a massive earthquake. And you can see the fault. It runs right through the bridge. And when a fault, it slips like this, the bridge just gives up. Okay, you guys can see where the fault goes, right? Something like this. Okay, and then here are some massive earthquakes in history around the world and here in Taiwan. And in the world, the Chilean earthquake in 1960, it is the largest ever measured earthquake in our history. And it measured 9.5 on the moment magnitude scale. And then it's the 1964 Alaskan earthquake. It is 9.4 on the scale. And then the 2004 Indian Ocean earthquake, it caused a big tsunami. You guys recall that? Yes. And also the 2011 Tohoku earthquake, which caused a nuclear disaster. Yeah. And in Taiwan, these four, they aren't the biggest, but because their center, the epicenter, Zhejiang, is closer to those densely populated areas, so they cause more damages and more lives than the others. So the 1906 Meishan earthquake, the 1935 Hsinchu Taichung earthquake, the 1964 Baidu earthquake, and the 1991 magnitude. So these are one of the most so they were more deadly than the others. Okay, now some questions for you guys.
The first question, how big was the 91 earthquake? It's very easy.
On the Richter scale, okay.
On the Richter scale. Just choose one.
0.3.
Alright, nice.
The second question. What did Danny do during the earthquake? The earthquake.
lie down by the couch and what?
And then what did he do? After the earthquake stopped.
They try to get out the building, but they don't take the elevator.
Okay. Don't spend time talking during an earthquake, okay? It's a complete waste of time. Really. Okay, so now name some difference between the local magnitude and the moment magnitude. I look at this.
Did you just name one difference?
And okay, maybe two or maybe one.
Can you remember one
The
difference?
local magnitude is the Richter magnitude, 类似地震规， and the moment magnitude is what we call 地震主规。
I know the answer, just one. I just got one. The local magnitude is more accurate for earthquakes happening nearer. Okay? Just got that one. And how about the other two?
Oh, and something more. How do we calculate this moment magnitude? We calculate it by measuring how much the fault has slipped, how much distance the fault has slipped. Because the bigger it slips, it means that more energy is released. This is a bit odd. All right, name the types of the faults. Give the correct one, okay, not the wrong one. Anyone want to try? In English? No? It's really easy. Want to give this a try? Alright, so what's this? Okay. This. What's this? This one. The left one. Anyone want to give a try on those two? Alright. Alright, what's this one? Come on.
Just show us the answers. That's the
Okay. So this is a dip slip fault. Okay. It dips into the ground. One of the plates dips into the ground, so we call that a dip slip. So this is a normal one, okay, and this is a reverse one. And also, we call this the hanging wall, 就是上盘. And this is the foot wall, 下盘. Okay, and this is the optic slip fault over there on the far left. Okay, now. Anyone's geometry is good enough for this? You? Okay, come on up and point it. Find it on this one. Eyes open. Hey. Okay. I mean, the whole thing. yeah, it's, like I said, it's 80 kilometers. It's really long. You can hear? A little longer. Maybe you'll just try again. Okay, so you think it's over there, right? Okay, so actually it is this long. It's really long. From all the way from the southernmost part of Miaoli to the southernmost part of Guangzhou. Okay, and this is the Shigang Dam. Yeah, it's fell apart in the earthquake. And this is the 921 Earthquake Museum. And this is the Cheolunghu Fault Preservation Gallery. And this is what they think that this volcano is.
What do you who is under the table? Anyone know? If you answer A, you can say Garlic. Chocolate.
Which animation has this lonely animation? When I know of the animation,
不知道左边那个。
知道哎。Final。这是什么棋盘？可能哈纳棋盘。I love it. It's very good.
Yeah, so thank those giving us the picture. I wouldn't bother to make them myself. Alright, thank you guys for listening.